A very good day to everyone who is watching. My name is Jothi and I'm presenting my research topic on leveraging HR analytics and machine learning to minimize employee turnover risk. This study examines how data analytics and predictive models aid HR teams in early identification of attrition risk and inform talent retention decisions. Let's start with an overview of the study. I will now explain on the overview of my research. Firstly, abstract, problem statement, objective, methodology, results and discussion, and finally conclusion. Now I would like to explain on my abstract. In this project, I addressed employee attrition which raises cost and lowers morale for organization using HR analytics and machine learning to predict at-risk employees. The approach involved data cleaning, dataset balancing with smooth, and feature selection for accuracy and improvement. Various models, including logistic regression, decision tree, and random forests, were trained and evaluated based on metrics like accuracy and F1 score. Power BI was also utilized to create interactive dashboards for HR professionals to monitor trends and to take timely actions. The study demonstrated that combining analytics with visualization tools can actually enhance HR strategies. Now I would like to explain on my problem statement part. Employee attrition is a growing concern for organizations, leading to operational disruption, increased recruitment costs, and lower morale. Predicting potential departures is very challenging as the traditional HR reports often miss early warning signs. Factors influencing attrition such as work-life balance and job satisfactions are very complex and interconnected. Thus, there is a need for predictive system using machine learning and HR analytics to identify attrition risk early and aid HR teams in making proactive decisions. The research is driven by five main objectives. Firstly, to explore and analyze HR data using exploratory data analysis (EDA) to understand the trends and patterns related to the employee turnover. Secondly, to identify significant features contributing to attrition by using statistical techniques and feature selection like chi-square and ANOVA. Thirdly, to develop and compare machine learning models such as logistic regression, decision tree, random forest, gradient boosting, KNN, and SVM for predicting employee turnover risk. To evaluate model performance using accuracy, F1 score, and also confusion metrics. And finally, to present visual insights through dashboards using Power BI to aid HR decision making. Next, I will continue with the research methodology. Step 1. Initial data preprocessing. To begin with, I used the IBM HR dataset which contained 1,470 employee records and 35 variables. I first examined the data types and checked for any missing values. And then I removed irrelevant columns such as employee number, standard hours, over 18, and employee count since they did not add any predictive value. After that, I standardized and renamed the column headers for consistency, making the dataset cleaner and easier to manage. Step 2. Data exploration. Next, I explored the data using several visualization and statistical techniques. I identified the unique value of categorical features like job role, department, to understand category diversity. I conducted the descriptive statistic to understand distribution, plotted histograms for numeric data such as age, and bar chart for categorical data like attrition by job role. Lastly, I used correlation heat map to detect relationship between variables, which helped to guide feature selection later. Step 3. Data preprocessing for model building. Before building the model, I applied further preprocessing. Outliers and numeric features were detected and handled using the interquartile range IQR method. I visualized these with box plot and identify extreme values. Then I used the min-max scaling to normalize the data, ensuring all numeric features were on the same scale. For encoding, I applied label encoding to binary variables and one-hot encoding for categorical variables like job role and department. Lastly, feature selection was done using ANOVA F-test for numerical features and the chi-square test for categorical one, so the models would only use the most relevant inputs. Step 4. Model building. Moving into the model building, I tested 6 algorithms: logistic regression, decision tree, random forest, gradient boosting, support vector machine SVM, and K nearest neighbors KNN. I split the dataset using an 80-20 train test ratio to ensure fair evaluation. To handle the class imbalance, since only a small portion of employees had left the company, I applied smooth synthetic minority oversampling technique. This helped to balance the dataset by oversampling the minority class. All models were implemented in Python using libraries like pandas and scikit-learn. Step 5. Model evaluation. Finally, I evaluated each model using three metrics: accuracy, F1 score, and confusion metrics. While accuracy gives a general idea of performance, F1 score was crucial as it balanced precision and recall, especially important in imbalanced data set. The confusion metric further helped to break down the model prediction into true positives, false positives, true negatives, and false negative, offering deeper insights into model performance. Next, I would like to explain on the EDA results. EDA provides a comprehensive overview of the dataset used for employee attrition analysis. The descriptive statistic table summarizes the central tendencies and distribution of numerical features such as age, monthly income, job satisfaction, and working years, indicating variation across employee. The categorical summary reveals that most employees do not frequently travel and primarily worked in R&D and sales department. The bar chart illustrates that sales executives and research scientists experience the high attrition rates, while the pie chart shows that attrition is most prominent in the research and development. These insights highlight patterns in job roles and department distribution that may contribute to employee turnover. Now I would like to explain on the Power BI dashboard. The Power BI dashboard provides a very quick overview of employee attrition. At the top of the overview, we see the total employees, number of leavers, and attrition rates. The pie chart highlights who left and from which departments. The scatter plot shows how income and working years relate to attrition, while the line chart reveals that attrition increases after several years at the company. The job role bar chart shows that sales and research roles experience more turnover. Lastly, the donut chart breaks down the data by gender, marital status, and education, offering deeper insights for HR decision making. Next, in this study, 6 machine learning models were tested: logistic regression, decision tree, random forest, gradient boosting, SVM, and KNN. We evaluated each model using both accuracy and F1 score to ensure fair comparison, especially the data had class imbalance. Logistic regression emerged as the best performing model with an accuracy of 83.64% and the highest F1 score of 0.4375, showing a strong balance between precision and recall. Although gradient boosting had a slightly higher accuracy of 84.09%, its F1 score was slightly lower at 0.4262, meaning that it was less consistent in predicting actual attrition cases. Random forest and SVM both had good accuracy, also at 84.09%, but their F1 scores dropped to 0.3137, suggesting weaker performance in identifying true positives. KNN and Decision Tree performed moderately with lower F1 scores, indicating they were less effective at handling the class imbalance. As shown in the bar chart, while accuracy looks high across most models, the F1 scores gives us better insight into how well each model truly predicts attrition cases. Next, I would like to explain on the champion model for my research. For this study, logistic regression was selected as the champion model. This decision was based on a strong F1 score of 0.4375 and balanced classification performance compared to the other models. The confusion matrix on the right breaks down the prediction. The model correctly identified 170 employees who stayed and 14 who left. It also misclassified 11 employees who were incorrectly flagged to leave and missed out 25 employees who actually left but weren't predicted to do so. Overall, the logistic regression model shows a good practical effectiveness in identifying at-risk employees, making it a reliable and interpretable choice for real-world HR analytics. Now I would like to explain on the recommendation part. This study recommends that organizations adopt predictive HR analytics to identify employees at risk of leaving. Focusing on key factors like overtime, income, and job satisfaction can help to improve retention. While advanced models like gradient boosting performed well, simpler models like logistic regression are easier to implement and interpret. For future research, using more diverse dataset and incorporating behavioral data and explainable AI can further improve prediction accuracy and transparency. Finally, I would like to talk on the conclusion part. This study showed that machine learning and HR analytics can effectively predict employee attrition. Logistic regression was identified as the best model, especially for handling class imbalance using SMO. Key attrition factors like overtime, income, and job satisfaction were uncovered, offering actionable insights. Overall, data-driven methods can help the organization to make smarter, proactive HR decisions. Thank you for watching.